get lost in the building sometimes, just because somebody's like, ooh, USB cord. Thank you, Mr. Hurry.
Mr. Cooper was like, someone stole my coffee, and I saw that on the camera, and his wife was in videos, and I was like, that's you! That's so funny.
It's like the lunch thing, like,
He was so
it
sad.
still boggles my mind why somebody would like go up to a refrigerator in an office and be like, oh, sweet sandwich, thanks. And just take people's lunch. And I remember hearing about that going, that doesn't happen. And people that I know that work in offices are like, oh, happens all the time.
That's why you just go into a different office and take their lunch.
Or why you sabotage your own lunch with like laxative.
Oh.
Which is illegal.
Is it?
No, it's your sandwich. It's your
My sandwich, I can do anything I want.
But then if they don't take it.
So, I mean, you don't have to make them like in the hospital, but you can make them. Wish
Rice
they
and
had.
burger.
If you did that in order to catch someone and they ended up dying, that's definitely intent to like.
That would be a problem. Yes. But let's move away from this since we are on video. So, all right, so here we go. A Norman window. In case you didn't know what a Norman window is, it is a rectangular window with a semicircular window, or maybe an oval one over the top. Ours is going to be a semicircle. So, a Norman window is constructed by adjoining a semicircle to the top of an ordinary rectangular window. Find the dimensions of a Norman window of maximum area if the total perimeter is 16 feet. And when I say perimeter, I mean that. Okay? So the perimeter of the window. All right, now I went ahead and labeled this x and x over 2. If it wasn't labeled at all, you could call this x and this 2x. Doesn't matter, but we're just going to go with this. Are you with me?
Yes.
Okay, so it says find the dimensions of a normal window of maximum area. So I'm maximizing the area, and how do I do that? What do I got here?
Area of the rectangle.
Area of the rectangle, which would be x times, I don't know, we'll call it y for now. So x times y plus what?
X halves pi r squared.
So half of a pi r squared, right?
Yeah.
So I'm going to do half of this and half of a pi r squared, but I know what? The r is x over 2, quantity squared, and now I got to figure out what to do with this y value. So do I know anything else that might help me with this y value? Okay, the perimeter. So, and again, every year I have somebody will have a problem, well maybe not every year because I don't use this problem every year on the test, but when I'll have somebody maximize perimeter. Again, be careful about really read the question. Some of you guys just read way too quickly and don't really gather the information. Now what would the perimeter, I know it's 16, right? What is the perimeter of something like this?
X plus 2y.
X plus 2y plus what? Half the 2 pi r. So I'm going to go x, perimeter is x, plus twice the y, plus half the circumference, and the circumference would be 2 pi r. So 2 pi x over 2, right? 2 pi x over 2. Y'all with me on that? Okay, so I can cancel a couple of those 2's out. I'm going to cancel that one and that one. And that leaves me 16 equals x plus 2y plus 1/2 pi x. Now I can use that to help me over here, right? Right? But I gotta solve for that y. So I'm gonna have this 16, I'm gonna subtract that x, I'm gonna subtract that 1/2 pi x, and that'll get me to here, and then I can finish by dividing by 2. So that ugly thing is my y. So here is my equation. X times all of that, 16 minus x minus 1/2 pi x, all of that over 2, plus, and again, you don't have to simplify this stuff if it's not manual. And people are like, well, I can't because I'm good. You probably are, but you're also human. And people forget, like right here, they do pi x squared over 4. Why is that wrong? Why is this not pi x squared over 4?
Because of pi.
because I'm squaring the 2 also, right? But that's a careless error people make, and it messes everything else up in your problem. And I can't see it. You know, if you type that in your calculator, it's just not worth the risk. Same thing here. I could divide each of these by 2 and get 8 minus a half x minus a fourth pi x. But why? Type it in like this. Then you can just say, all right, the derivative of a equals 0 when x equals blank. And I believe you get 4.48-ish. 079 ... Do that and just check and make sure you're good. And then of course I'm going to say and a is maximized because what? A prime goes from plus to minus here. And then it says, what are my dimensions? X, Y, I'm going to go with X, Y, and R.
Mine says cannot accept
Yeah,
change,
mine won't let me do it.
variable in use.
Mine won't.
Sorry. I did it this morning and I had no issues. Let's see.
That's what happened with one of mine last night.
Yeah,
I had
that
to, like,
was really
simplify
bad.
a bit.
Yes,
Yeah.
yes. You, it wouldn't
I
let me,
really
like,
don't wanna
it
say
wouldn't-
Okay, hold on. Let me see what you have in there. Who got that message?
I
You
know.
just got it?
Yep, that's what I got. I got it.
Okay, watch this. I'm thinking this might be it.
I mean, I had to think about it for a second, but it was
Right
really
there.
Times.
Oh. Okay, guys. If your calculator says error, do not accept change, and it's 84s won't do this. Put a times right there. Just do that. I start putting it in there all the time. And I don't know why the Inspire is picky about weird things like that, because it shouldn't be. And you don't have to be on the 84. But sometimes you get weird things. I just go back in there and put times, 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 and start seeing what happens. Did y'all get 4.48079?
I got 3.4 or something.
I got way better.
I got I think it's time for me to
It changed back the equation.
Oh, you don't have a squared on that x over 2. You don't
Oh,
have
yeah,
it.
I got that.
Put that x over 2 squared.
Yeah, I have one.
And guys, that's another thing too. Like, if you have everything set up but you type it in wrong, I mean, you're going to get most of your credit, but you're going to lose the x. And you're going to lose this. In this case, that would have been 4 points. You got to really be careful and go back and check, double check, learn from these mistakes. Really be careful when you enter your stuff. Now tell me what I'm going to do to find x. Nothing. That dimension is 4.481. What am I going to do to find y? I got to plug it into that. Are you with me? So take your time and plug it into that. That's going to give you 2.240. And then what am I going to do to find the radius? Divide the x by 2. And that's going to be also 2.240. Y'all seen that? Right. All right, check out this next one. People, I've given this multiple times on tests before. We'll see if it's on this one. But this particular one, it used to just destroy my students. And then I started labeling the graph a little bit because really their mistakes were more about the geometry than they were the calculus. And I don't want it to be all about that. I don't want you to lose 8 points just because your geometry skills are a little shaky. So I started labeling this a little better. So here we go. Area of the largest isosceles triangle that can be inscribed in a circle of radius 4. So what am I trying to find?
The area.
I'm maximizing the area of the triangle. So I'm going to start with area equals 1/2 base times height. Now I did do one thing here that was maybe a little dirty, and then I put h in there, and you're thinking h is height, right? But h is not the height of this triangle, is it? So that's why I started out with this. So let's start filling this in. My base of my triangle would be 2x, and my height would be h plus 4. So at this point, you probably were to get some points already, but I still have an issue with x and h. Now, I said something on this that was kind of a little odd. I said, solve by writing the area as a function of height. Now, most people probably wouldn't do that. Most people would probably come in here and go, all right, how am I going to find h? You tell me. Actually, this will be the same either way. How can I rewrite h in terms of x based on what you see here? Pythagorean theorem, right? You know that 4 squared is h squared plus x squared. And I gotta be honest with you, I did this key this morning, and you know what I did? I took that 16, I subtracted the h squared, I square rooted both sides. Actually, I'm sorry, I did not do that. I did this. I took that 16, I subtracted the x squared, and I square rooted both sides, and I replaced h with this because I like x. And there's nothing wrong with that, except that this question said solve by writing the area as a function of the height. So if I'm writing it as a function of the height, I want h in my equation. Does that make sense? So what I don't want to do, I don't want to do that. I want to do this. So I get x equals the square root of this. And by the way, in no world is the square root of 16 minus h squared 4 minus h. Okay? In no world. Not today, next week, anytime. Okay? Please don't do that. That's a huge assault on the rules of algebra. Okay? I know you're like, why not? Because that factors into this, right? And the only way you simplify stuff is if they're the same. They're not the same, so nothing comes out. You're just stuck with that. And besides, why even risk simplifying anyway? AP doesn't care about the simplifying. Just put in there what feels good and leave it. So there's my x. I'm going to plug in right here. And if you wanted to cancel that 1/2 and the 2, I think you're all pretty comfortable with that, right? So I'm going to replace this 16 minus h squared h plus 4. And at this point, I can start the process. So, what are we going to say? Area is maxed or maximized when, at h equals. Now, how do you type this in your calculator? Since I know you can enter h, but your calculator does not work that way. So what are you going to have to do when you enter it in? Yeah, you're going to put it in as x, but don't make the mistake of actually thinking that the x your calculator spits out is that x. The x your calculator spits out is that h. So we're going to let it be x while we graph it, but you have to remember that that x you get is really the h. And when you do that, you should find that h is 2. Now, when I first did it, I did not get h as 2. I got error, no root, something, something found. So I had to go back and put a times in here. Actually, I had to erase it all, but the second time I put a times in there and it actually worked. So it's maximized there, and I know that because a prime equals 0 and goes from plus to minus.
Yeah, the graph was weird.
It was.
Was it? I erased that one.
It's a straight line.
And remember, if you're thinking about domain, guys, if you're thinking about the domain on your window, like what do you go from? Well, x can't be, or h right here can't be 0, and the biggest the height can be is 4. So set your window up on your x's from 0 to 4. And that way you don't get any extra crosses that potentially could happen. And then the last question is, says find the area. So the area, I'm going to go back, and my area is essentially f1 of 2. And when I do that f1 of 2, I don't have to write the f1 part, or a y1 of 2, whatever calculator you have. When you do that, it spits out 20.785. And it just didn't give me units, so I'm going to put units squared. I will say this, in APCAL, units are a big deal, but if they ever don't give you units, they generally don't care. If they do give you units, they generally care. So this one doesn't, so if you don't put them, I'm not gonna really quibble about that, but if it said inches, make sure you put inches squared, because that very well might be part of the points. How we doing?
Not bad.
All right. Y'all think you would have gotten that on your own?
You know.
Let me ask you
Definitely
this.
know what that
If I didn't say right as a function of x, or h, would you think you would have gotten it on your own?
I don't think that changed.
All right, how about this? Do you think you'll get it now?
Yes.
Okay, again, that's why I want you to do these problems at home so you'll have seen them. This is as much about learning from this and just remembering what you learned than some new process. All right, last one's kind of tricky. I probably won't be able to set it up, but it's very similar to that one we did with the roads, the dirt road and the paved road.
Oh.
Okay, and this one actually would be a very real life situation, except it would probably be more involved than this with regulations and all this kind of stuff. But this next problem is talking about, all right, we got this offshore, what's that?
That's maritime law.
Oh, yes.
Ocean.
So I've got an offshore oil well. So let's just say we've got this oil well out here, and it's 2 kilometers off the coast. So I'm just going to draw 2 kilometers, and then here is our coastline. Okay? But unfortunately, the refinery is not right here, 2 miles directly in front of it. It's way down here, which is probably not even remotely true, but let's just say it was. All right, and it happens to be 4 miles. 4 kilometers total.
There's a point right there.
Right. That's 4 kilometers down there. Now, it turns out that it's twice as expensive to build in the ocean, which makes sense, right? You're gonna have to take this pipe, put it at the bottom of the ocean, there's all that. Well, putting it on land, you're just probably gonna bury it and upset some people, perhaps. But anyway, the question is, if I put all of it on land, all of it in the water, it's gonna cost me a lot more money. If I put it very little in the water, like go straight there and come over, it still might not be beneficial. So more than likely, now it might be, we might run the numbers and it's cheaper to go straight there and then over there on the land. We might run the numbers in a second and see that it's cheaper to go straight to the refinery. But the calculus will let us know that. So what I do is I draw a picture and say, maybe it's partially in the water and partially on the land. And then the calculus will work out and tell me what the variables are, and you can adjust it. All right? Now, the only thing I know is that it costs twice as much here than it does there. So what do you think's getting related here? Cost is related to what? It's distance. Y'all seeing that? So right here, it's going to be twice as expensive as it is going to be here. But it's still about distance. So does that make sense? Because it's price. Now, if I'd have told you it was $5 a mile, $5 million a mile, or $5 million a kilometer, I could just put 5 and put the price in there. But it's a ratio, I know. So it's going to cost me twice as much. So when I think about cost, cost is a function of these distances, right? The first distance right here and the second distance right here. But this one's twice as expensive. Are y'all seeing that? Okay, so twice what it would be there. Now all I gotta do is figure out these D values. So all I know is that I don't know anything about the distances right now except that's 2 and the total's 4. So remember what we did before? If this is 4 total, some of it's there, some of it's there. So I like calling that X and this 4 minus X. Now I could flip-flop that and call this 4 minus X and that X. But at least at this point I've got the second distance. So the second distance, 4 minus X. Now to find this first distance, what do I now know about this that will relate me to that? Pythagorean theorem. So here I now know, all right, d1 squared equals 4 plus x squared. And if I solve for this, I get my d1 value. So I can take that and plug it in here. And even though I won't actually get a cost, what I will do is find out what lengths would give me the cheapest cost. Does that make sense? So if I'm trying to minimize my cost here, I won't know what it is, but whatever it is, it's gonna be the cheapest possible based on this to this kind of ratio of built pipeline. And this kind of thing we could actually do. I wanna do this manually even though we have a calculator. No, I don't, because I don't have time. So in this case, I'm gonna say the derivative equals 0 at x equals,
Don't you also want to say C is minimized when the derivative is 0?
well, I'm not finished yet. Well, yeah, as long as you say it somewhere.
Okay.
So C prime equals 0 at x equals, I got 1.15470-ish, right? And C is a min because C prime, I've already said equals 0, so because C prime goes from negative to positive here. And then the question was, what path should they follow? Now, again, I'm not gonna ask vague questions. I mean, that sounds like, am I supposed to figure out the angle? Whatever, so what I just did is said, I just found the distances. So the D1, your first distance, which is gonna be you're in the water, is gonna end up being 2.309 kilometers. And my D2 ends up being just 4 minus x, which is 2.845 kilometers. And how would you find that D1 again? Tell me, how did you find D1? Plugged it in there. And how did you find D2? Plugged it in there. But technically, you're not really finding cost because cost really isn't equal to that. It's kind of like a relationship there. But I can still use that. I'm not minimizing distance, right? I had to think about it in terms of cost by putting that 2 in there. So anyway, at least at this ratio, as long as the price on land is twice the price on the water, this relationship will work for me.
So tonight we're doing the.
Yeah, so do that. Now there is actually a little homework assignment too. But again, I don't care at this point if you know the process. Just look at them and see if you can set them up. That's the main thing probably at this point that could do you justice.